Hello, everybody. So here is the third set of notes for vectors. Today we are going to talk about something called component form. Now, we know that vectors are directed line segments. So on the side here, what I'm going to do is I'm just going to draw a vector. I'm going to say that this point is 2, 2, and this point is, let's just say 5, 4. Okay, I'm just doing this off the top of my head. And let's say there's a vector that goes from 2, 2 to 5, 4. All right. Remember, vectors have a tail and a tip, right? And they have a direction. So the length of this line would be its magnitude, and then the direction would be the slope of the line, right? So one thing that we can do is we can take any vector, no matter where it is, and we can put it into what's called component form. Now, what component form is it separates this vector here into two components. It separates it into the x component, which in this case is 3, because it goes over 3, and the y component, which in this case is 2. So this vector could be written as 3, 2. This is called the component form. Now, one thing that's nice about component form is you can get it just by moving any vector's tail to the origin. So for example, let's go back, let's look at this. Let's say that if I wanted to put this into component form, what I can do is move this point left 2 and down 2. So this would be 0, 0. So you make the tail the origin, and then you move the other one the same way, left 2, down 2. And this point would then be 3, 2. So putting something in component form is the same as translating it to the origin. All right, so there you go. This is called standard position. So standard position is when you translate or you slide a vector's tail to the origin. Okay, and by putting it in standard form, you are able to make it component form. So the component form is always written like this, A comma B, but there's not parentheses. There's little arrow bracket things. And the reason that those are there is because this is not a point. This is actually representing the whole vector. This represents the vector with 0, 0 as one end and AB as the other end. So that's called the component form. Now, if you're going to look at component form, then what you want to think of is this. The magnitude of a vector that has 3, 2 is you don't have to do the whole formula. All you have to do, instead of doing x2 minus x1 squared plus, all you have to do is it's a squared plus b squared. Since one side is 0, you don't have to do, if it's in component form, you don't have to do the whole distance formula. And then let's think about the direction angle. So again, if I have this vector here, and the direction angle is going to be this angle right here. Well, let's think about it. Let's bring this back to trig. If the x value is a, and the y value is b in this case, right? We know the tan of the angle equals b over a, right? So in other words, it's going to be second tan of b over a is going to give you the direction angle. So those are the two formulas that we need to know. Now, with all that said, let's do a couple examples. So we have this vector here, 7, 24. Now what that means, just so you remember, is it's a vector that has a 0, 0 tail and a tip that is 7, 24, right? Just keep that in mind. That's what this means. This is representing a vector. It's the component form. This is the x component. That's 7 is the x component, 24 is the y component. All right? So if we want to find the magnitude of vector r, so the magnitude of r equals, it's just the square root of a squared plus b squared, which is square root of 7 squared plus 24 squared, which that's 49 plus what's 24 squared? Let me get my calculator out here. I should know this, but I don't. 576. So square root of 49 plus 576 is 625, which is a perfect square. The square root of 625 is, hold on, square root 625 is 25. All right, so that's the magnitude of that vector, or the length of the line. So again, if you wanted to do a squared plus b squared equals c squared for that, you could. Or you could do the distance formula with one side being 0, 0. Again, that would work also, but this is a little bit quicker. The other one is, if I want to find the angle, there's going to be tan -1 of 24 over 7. So that'll tell you the angle that that vector is moving. So second tan of 24 over 7 is about 73.7 degrees. Okay, so that's how we do this. Now we can do this for all 6. We are not going to be doing all 6. I'm going to just do a few here and there. Let's do number 3 next. Okay, so the vector we want to find, again, this is 8, -12. So you don't have to draw these every time, but I just want you to kind of get a visual. This means you're going right 8 down 12. This point is 8, -12, but this represents the whole vector with 0, 0 on one side and 8, -12 on the other side. Okay, so first thing we want to do is find the magnitude, or the length of that vector. So square root of 8 squared plus -12 squared. Now remember, when you square that, it becomes positive anyway. 64 plus 144 is 64 plus 144 is 208, which is not a perfect square. So we could either leave it as square root of 208. We could reduce it. That one does reduce. 208, you can put 16. Yeah, 16 and 13. So it'll be 4 radical 13 is the magnitude. If it said to round to the nearest tenth, you could just type it in. You know, those are all fine. And then to find this angle, okay, what you want to do is do second tan of. Now, here's the trick. We know that this angle is going to be between 270 and 360. We know that because we're talking about the direction angle. So it's actually going to be that right there. So when I find the angle, I don't do negative. Remember, I want a reference angle, and then I'm going to subtract it from 360. So I'm just going to write 12 over 8. This is just going to give me my reference angle. Then I need to put it in the 4th quadrant, because this is in the 4th quadrant. So second tan of 12 over 8, let me do that really quick, is 56.3. Okay? But I want it to be in the 4th quadrant. So I'm going to put it in the 4th quadrant. I'm going to do 360 minus 56.3, which is 303.7. That is the angle of the direction of that vector. All right? So let's go ahead and let's go to number 5 now. So number 5 is very similar. This one, let's see if you can figure out what quadrant is that one in. -2, -8. Well, it's going to be in the 3rd quadrant, and it's going to be this vector right here. It's going to be a vector that starts at 0, 0 and goes left 2, down 8, right? So that's this vector right here. So to find the magnitude, you do a squared plus b squared. Well, 2 squared is 4, 64, square root of 68, right? Now, 68, if you want to reduce that, again, 68 You can do 4 and 17, so this will be 2 square root of 17. Now, we've done a lot of these. If you still need help with these, I can give you some resources on how to reduce those. All right, then we want to know the direction angle. Well, when you're doing this, again, don't put the negatives in. Only do the positives, and then we need to put it in the third quadrant. So we're going to do 8 over 2, which is second tan of 4, right? 8 divided by 2 is 4. So I can do second tan of 4, and you get 76.0, and that's what I need to put in this quadrant. So I need to add it to 180 to put it in that quadrant. So in quadrant 3, it's going to be 180 plus 76.0, which is 256.0. Now, if you want to try these, see what they look like. I will be posting all these filled in just a little bit after I give you an assignment. But that's it for today. So let me know if you have any questions. Make sure you get this down. After tomorrow, I will be giving you an assignment for everything we've done so far. So just make sure you're following along and asking questions if you got them. All right. Thank you very much.